In this tutorial, we're going to look at how to use Forest Pack to create rugs by scattering small patches of actual geometry. This approach benefits from allowing you to precisely model the pile for your rug in as much detail as you need, a thread at a time if necessary. Thanks to instancing, in most cases it will also use less memory and render faster than displacement or hair and fur approaches. Whilst we're considering what's under our feet, we will also look at how to create two types of fully parametric wooden parquet floor using rail clone. Texture-based approaches have their limitations, so by using real geometry we can add subtle transform randomization, as well as using a simple technique to disguise texture repetition and add a random value tint to individual planks. The majority of this tutorial can be completed with the free versions of Forest Pack and rail clone. To create the floor, we need to define the boundary of the room using a spline. To do this, enable vertex snap and draw a closed spline around the perimeter of the room. How accurately you adhere to this boundary depends on if you are creating renders in adjacent spaces. If you're not, you can simply create a large rectangle that's big enough to encompass the entire area. We also need a single wooden plank for the floor. So just create a box of the desired size and enable generate mapping coordinates and real world map size. Finally, add a chamfer modifier to crack the arris. Then create a new rail clone object and open the style editor using the button in the style rollout. Add a new A2S generator. This node is used to create two-dimensional arrays. Automatically size the array to fill the spline created in the previous step by adding a spline node. Pick the spline from the scene and wire the node to the generator's clipping input. Enable extend XY size to area, then next create a segment node, wire it to the default input and use it to pick the floorboard object from the scene. And voila, you will now have a simple floor, but all the joints are currently in the same line. So to randomize the rows so that the joints are offset, firstly add a new transform node to the generator's start input, and then wire the existing segment node to that transform node. We will randomly move the start segments to the left so that they're clipped by the spline, but we really never want this offset to be larger than the length of a single board. Usefully, we can automatically find the size of the segment and use it to drive any parameter. And to do this, you just right click on the segment node and select Export Attributes, X Size. Next, select the transform node and export the left padding property. Click the padding checkbox to enable the transform node to override the segment's own settings, and then wire a new random number node to the left padding input. Change type to scene units and the generate on option to segment. Export the max scene units property and wire it to the segment's X size output. This will add a random padding value to the start of every row, but because the number is positive, the boards are currently moved to the right, away from the boundary. To fix this, we need to convert the segment's X size to a negative value. In addition to the core nodes we've already seen, Railclone includes several handy macros to add extra functionality to your graph. You can see a full list of these by choosing the Macros tab from the items list. In this example, we'll use the invert value macro to automatically turn a positive number into a negative, and vice versa if you need it. Wire the invert value macro to the random number node and wire the segment's X size attributes to the macro. You'll now have a floor with randomly offset joints, and because the distance is based on the size of the segment, you can easily change the size of the plank and the style updates automatically. So this is the first type of floor complete. Now let's take this and turn it into a herringbone style to create a second type of floor. So delete the nodes we just created that are connected to the start input. Find the macro called segment herringbone and wire it between the segment node and the generator. This macro takes care of all of the calculations required to create a herringbone floor. All you need to do is to change the size of the plank by editing the source geometry. If the boards don't quite reach the perimeter of the floor and there's a gap, increase the generator's clipping area expand property to enlarge the array. and you can now easily add randomization to the planks using the segment's transform random properties. Avoiding repeated textures on a wooden floor is often a challenge, but RailClone has several features that can help to disguise it by manipulating the UVs and the maps themselves. In this example, the material uses a single tileable diffuse map that will randomly offset to hide repetition. To do this, add a UVW Xform node between the macro and the generator. Enable random offset and use the same values used for the map's real-world size. For additional variation, you can also add a RailClone color map to the material and enable tint override to subtly randomize the colors or brightness per plank. Here's how it looks with UV and texture randomization. RailClone can be used to parameterize nearly anything that has repeated elements. For example, in this scene there's a radiator model on the back wall. It's been created by slicing a model into 6 repeatable parts. These are wired to an A2S generator, using mirror operators to reuse the segments created for the left-hand side of the radiator to create the right. The length and the height of the array have been exported to numeric nodes so that it's easy to change the size of the radiator directly from the modify panel. So with the floor finished, we can turn our attention to the rug. Rugs come in many shapes and sizes, so the easiest way to define the footprint is to draw a closed spline from the top viewport. We could use the spline to simply scatter rug geometry onto the floor, but in reality, rugs have a fabric base which is often visible around the perimeter. So to mesh the spline and add some thickness, just put on a shell modifier and then an edit poly modifier. Add some edge loops and then add a turbo smooth modifier, plus some noise if you want to create a slightly uneven surface. So this kind of base is fine for a flat rug or if you're using Forest Pack Lite, but the advantage of using a spline to define the shape is that you can use the cloth modifier to add wrinkles and create a more lived in appearance. So we'll do this, delete the existing stack and instead add a garment modifier. Increase the density parameter to add subdivisions. The more of these, the slower the simulation, so you should aim for a balance between speed and detail. Create a large box below the rug to act as a temporary collision volume to speed up sim times. And finally, add a cloth modifier to the rug. Open the object properties, change the current object from inactive to cloth, and pick an appropriate preset. Enable Use Collision Object Friction. Click on Add Objects and select the box. Change the mode to Collision Object. If we run a simulation now and drag faces to edit the rug, more often than not you'll find as it simulates the rug will end up flat again. This is because there's very little friction, so the rug always slides back into its starting position. To fix this, increase the collision object's dynamic and static friction values. Now we can start manually manipulating parts of the rug to create wrinkles. In the cloth modifier, change to face sub-object level and turn on live drag. Enable simulate local and select and move a face. You'll see that the rest of the rug simulates for as long as the mouse button is depressed. If you want to run the simulation continuously, disable the sim on mouse down checkbox. And using these simple tools, pick up edges and areas to define wrinkles. For example, by moving polygons up and then to one side. If things go disastrously wrong, you can easily restore the original shape by selecting Reset State from the Object Rollout. Once you are happy with the shape of the rug, add a shell modifier to give the surface some thickness, and then a turbo smooth modifier to smooth out the wrinkles and soften the edges. Next, we need to create some small patches of fibres to scatter with Forest Pack and create the rug itself. The technique for modelling these depends on the type of rugs you wish to create, but to illustrate the workflow, we'll create a typical shag pile. So from the front or side viewport, draw a spline that's approximately 3 to 5 centimeters high depending on the rug you're creating, and then divide the length into 10 so that there are enough vertices to deform smoothly. In spline sub-object level, move the spline slightly off center and clone it so that you have 2 parallel lines. Add a twist modifier to create a double helix, and use the limit controls so that the top end looks as though it's starting to unravel. Add a noise and bend modifier to add some chaos. Clone this object and edit the modifier settings to create a few variations. Then when you're finished, assign a fabric material to the threads. If we scatter individual threads like this, we'll end up with hundreds of thousands of objects. So to optimize the scatter a little, it's better to create one or more small patches of pile and then nest them inside a second forest pack object for the final distribution. To create a patch, add a small circular spline, 1 to 2 centimeters, and use it as the distribution area for a new forest pack object. Add the threads to the items list, set the distribution map to full and adjust the density to fill the area. Enable scale and rotate transformations and adjust the settings to add more variety. Now we can create the rug. Add another new forest pack object by selecting the rug surface created earlier. In the surface rollout, ensure that the direction slider is set to 0 so that the threads rotate to follow the wrinkles on the base. Add the patch to the items list and change the distribution map to full. Reduce the density parameter until no gaps are visible between the patches. And finally, add randomization by enabling scale and rotation transforms and adjusting the minimum and maximum parameters. If we render now, we have a nice single coloured rug. We can add some more interest though by controlling and randomizing the colours of the threads. For example, to create a rug with different thread colours, apply a forest colour map to the material's diffuse input. Enable a map slot and pick a colour for each variation. To apply a random colour to each thread as opposed to each patch, change the Get Colour ID From setting to Element. You can also adjust the chance for colour being selected by using the probability values. If you need to match a specific rug pattern, you can easily tint threads using a bitmap. For this to work, a correctly UV mapped surface must be used. In Forest Colour, enable the Tint Override settings and load your bitmap into the Get Colour by Map slot. Change the mode to As Texture on Surface and change the blending mode to Normal. This mode is not able to change colours by element, so you'll need to use smaller patches if your pattern contains many tiny details. Finally, some rugs contain several types of pile. In Forest Pack, this effect can be recreated by matching an item's colour ID to the colour on a map. So in this example, paint a map that has a clear and distinct solid colour for each pile type. Then add the patches as normal to the items list and change the colour ID to match the map. Go to the distribution rollout and change diversity mode to match ID on map and add your bitmap to the map slot. If necessary, you can choose a different map channel and add some random noise too. So far so good, but what if we need to get a bit closer? For extreme close-ups, the threads we've created to date may not contain sufficient detail to look realistic. To add additional detail, let's go back to the original shag pile geometry. We need to remodel this from individual strands instead of a solid mass. We could use Max's native hair and fur modifier, but why not stick with Forest Pack? First of all, make an individual thread by creating a bent triangle from a plane, with the point aligned downwards on the world y-axis. Add this to a new Forest Pack object and use the existing thread geometry as a surface. Change the mode in the surface rollout to UV and drag the direction slider to 0. In the distribution rollout, change the map to solid. Uncheck the lock aspect ratio option and then adjust the X and Y density size to add more hairs. Adjust the rotation of the hairs from the transform panel so that they follow the length of the threads. But it's a bit too neat at the moment, so let's add some flyaway hairs. Increase the X rotation max value until some of the hairs are almost perpendicular. Enable probability curve and then change the graph so that there is a high probability of hairs following the thread and a much lower probability of flyaway hairs. Duplicate this forest pack object to do the same thing for the other threads. Make sure that the pivot point is at the bottom of the threads and then choose the patch object. Update the objects within the items list to the new high detailed versions. Remember, this patch is nested into the main rug object, so these changes will cascade through and update automatically. If you now move the camera close to the rug and render, you should find that the new detailed geometry stands up much better. So this technique works well for rugs, but it's equally useful for any other fabrics with a long pile. To finish off this tutorial, let's look at another example that uses the same technique to add a towel on the radiator in the background. Start by isolating the radiator and drawing a rectangular spline above it the size of the towel. Add a garment modifier and increase the density value so that there's sufficient resolution for smooth deformation. Add a cloth modifier. Open the object properties and change the towel to a cloth object. Then add the radiator as a collision object. Rotate the towel before starting the simulation so that it lands down onto its edge. This will create more interesting wrinkles than letting it land flat. Click on Simulate Local and, well, wait. The detail in the radiator geometry can mean that it takes a while to simulate. Once you're happy with it though, add a Turbo Smooth modifier to smooth out the folds. Unlike the rug, you probably don't want this mesh to be visible, so open the object's properties and deselect the renderable checkbox. We can now add clumps of fur with Forest Pack. So add a small clump of tufts to the new Forest Pack object, and then add the towel mesh to the surfaces list. Change the mode to UV and the direction to 0 so that the items are distributed across the surface. Change the distribution map to full and adjust the density until the patches overlap by about, well, 25% is good. Randomize the Z rotation and the scale to disguise repetition, and when you're done, hit render. You now have a towel with tufts of fabric. Many more types of soft furnishing can be created using this technique, so experiment and have fun.